Wow, this is really exciting to be one more year here. It's a really, really packed room, and I think we sold out. So thank you everybody for coming. This is, again, amazing to be here. So I'm Javier de la Torre. I'm the founder of CARTO. I got a lot of really exciting things to talk today. But before that, again, we've sold out, but I don't think it's possible, to change this location. I just cannot really think of a better place in London to organize the Spatial Data Science Conference than the Royal Geographical Society. So I invite you, if you haven't been here before, to explore the building. There's a lot of maps and interesting objects, so if you're into geography. So yeah, so I think we're gonna have to stay with this size, because I just really want to stay here. Now, I want to first start thanking the sponsors of the event. We got some great sponsors like always, and this conference wouldn't be possible, would not be possible without them. But even more, I think you have all of them with booths outside. I highly recommend that you go and visit them. There's been a lot of changes going on 2023 and 24 on a lot of the technologies and the data that they're providing here. And actually, this set of sponsors represents very well our industry, right? It represents the technology that we use, and it represents the data that we also use in our industry. So that mix of ingredients is great. So I highly recommend that you pass by, and thank you to all of them. Now, yesterday we also had 6 great workshops that many of you attended. I had the opportunity to be on a few of them. We talk about flooding, we talk about raster analysis. There was also around mobility data. To me, it's a very, very important part of the whole Spatial Data Science Conference experience. It's where we actually get to go deep into trying and and learning and seeing how things. Today we talk a lot, but that's actually where we actually get to see things being done. So I highly recommend if you haven't to attend on the next ones. I want to thank everybody that put into organizing them, attended, and also prepared the talks. It was great. I really loved it. But before that, I thought now starting to tell a little bit about my own personal history, because it connects very well with what I think with what I want to talk today. So I started my personal career not far away from here at the Natural History Museum in London, which is an amazing place, as you all know, and that most of you have visited, but you probably have not visited what is behind the curtains or behind the scenes. It's these type of museums hold some of the most important biological collections in the world. So they host enormous collections of specimens that have been collected by scientists around the world. That is the basic information that we use to understand biodiversity. So all of those specimens that you see in there on some of those images represents then later rows on a database that tell us, this species was at this location in this particular time. So it's the fundamental data that we use for biodiversity analysis. And I was working on mobilizing and making standards and technology to mobilize and open that data. And it was through that that obviously, one of the first things I wanted to do was to go and represent that data on a map. At the time, it was around 400 million records that we had already available. This is right now 2.2 billion that is now publicly available through the Global Biodiversity Information Facility. But it was a lot of data. And I've never done a map before. I thought it shouldn't be that hard. But it turned out that making a map of 400 million points in this case was actually really hard. It took me quite a lot of time. And this is actually not the map. This one looks way better than the first one that I made. But I think you probably share, with all of you, once you start making maps, it's very hard to look back. So yeah, that's how I really fall in love into geo. But something really became very clear to me, and became the foundation of what is CARTO. So in order to make this map, ended up having to create technology, and that technology to make this type of maps became the origins of CARTO as a company. And if something was very apparent is that making these type of maps and doing this type of spatial analysis was just not easy. It was actually pretty hard. And this is the mission, and was the vision when we started the company, was this is an amazing technology, spatial analytics, that should be in the hands of many more people. There's a lot of potential, and we all know it here. We all know work in this field, how important spatial analytics is, but it's pretty hard. And the vision of CARTO as a company and myself is really, If we can enable a bigger democratization, if we can enable more people to actually have access to this type of technology, that will have a pretty big impact in many areas. So today I want to tell you about how we're like looking at doing this. And actually kind of like focus on one of what I think is the main strategy, which I'm calling breaking the GIS data silo. You're going to learn more about this. But that's actually how we got into this. Now, the first customer that we got at CARTO, and still a customer, was the World Resource Institute. It is an organization that manages many kind of like conservation and projects around environment. But you know that around 10 years ago, together with us, launched Global Forest Watch 2.0. It's a platform that allows you to visualize and keep continuous eye around deforestation worldwide. There was no way to kind of go and easily see deforestation in almost real time. And that was the first platform that we built in there, right? And I just cannot be more proud of the impact over these last 10 years. There's been a lot of users, there's millions of users using this platform, there's been stories and cover, changing like companies' behaviors. So it has got a lot of impact, mobilizing this type of spatial data. But unfortunately, the reality is that deforestation remains one of the biggest challenges that we have. Still today, I mean, like there's huge amounts of primary forest being deforested, like as we speak, right? And so that's why I'm very excited about and have a very big hope with a new regulation coming on the European Union, the so-called European Union Deforestation Regulation, that essentially kind of like mandates companies that are sourcing, that are kind of like buying commodities such as palm oil, wood, soybeans, cattle, cocoa, coffee, and rubber. If they're importing any of these goods, they have the mandate now to check if those goods come from places where there's been deforestation since 2021. So this is the first time we have a strict regulation that says like, no, it's not voluntary. You have to check, you have to do a due diligence, you have to really see and demonstrate that there's no been deforestation when you were sourcing those goods. And that's a pretty big deal, I think, and it's coming into effect. It is already in effect, but companies will start reporting in January 2025. So it's a very big deal. It's right now a lot of momentum towards protecting it. There's a lot of lobbies against not making it happen, saying that we're not prepared. And in fact, actually, this is one of my first calls I want to make you. Fundamentally, to comply with this regulation, we do actually do it by doing a spatial analysis and checking if those farms that where the sources are coming have actually been deforested. There's been deforestation. It's a spatial analysis. A lot of people are saying that we're not ready. And that's actually, I mean, I truly believe, on this industry, we're more than ready to go after this challenge of, how we can do this spatial analysis. There's many more other challenges around this regulation, but the spatial analysis and the integration data problem still remains there. And this is actually how we look at, we're working at CARTO to solve it. So I think it's a very good example also of how a lot of models will integrate the spatial analytics. So you look at this data starts normally at software called ERPs, SAPs, right? That's where companies have their data around where their suppliers, and when they're going to buy some commodity, there's one person there that chooses this, that provider, and and then that's how they actually proceed the order, etc. So that's where we want to integrate that data. So they have that data around their providers, and those providers, have their farms. So we federate that towards the modern data stack, like BigQuery, Snowflake, Databricks, right? So that then later we can use platforms such as Google Earth Engine to enrich those polygons with information around deforestation alerts. And with that, make a report that becomes that due diligence that the companies have to actually perform. And then finally send it back to SAP so that at the end, the person that is selecting the provider can actually say okay, high risk on EUDR compliance by this provider, and here's a report, I can check it, and so on. That's how we are, in a way, enable this organization, these users to actually comply to EUDR. Now, this is a report. This is how it will, an example report of how it will look like. So in this case, I mean, like I'm looking at a set of farms by a particular mill, by a particular provider, and we see, like we can actually see there's been what are the alerts from the deforestation perspective and so on. That's so for you to get an idea. This is not only the entire compliance, but a big part of the due diligence is making something like this that demonstrates that you've done a good check if there's been deforestation in the places. Now, in order to do that, you've seen these data pipelines, and in order to make it in a way that is seamless for these organizations, we've actually called, like, as you know, I mean, like in CARTO, very big proponents of making it accessible through technology such as SQL. So all this data pipeline that you're seeing, it is now possible to make it directly on SQL and design with CARTO workflows, in this case visually, but then execute it on your native data warehouse. And that means that we are in there, like looking at your polygons, calling Earth Engine, taking deforestation data, preparing all that report, all natively on your platform. And to me, this is a great ideal. There's no like a lot of data moving to GIS tools here and so on. This is technology that a lot of companies have already accessible. Now, the methodology for doing that check in terms of like has been deforestation or not, the EUDR compliance analysis, there's going to be many of them. So CARTO actually has decided to join the Forest Data Partnership, which is an organization funded by FAO. There's a talk later about it, WRI, Google, who are actually kind of like trying to convey the idea of like, let's do this in an open way. So the methodology for doing it has to be transparent. So the Forest Data Partnership has been publishing on GitHub all their methodology. They call it convergence of evidence approach, to essentially like, so how you could do this type of due diligence. And we are applying that methodology on the solutions that you've seen. Very excited about this partnership. Yeah. Now, in order to do this, we also had to upgrade at CARTO's a lot of capabilities, especially around raster capabilities. So we've had, like raster capabilities in CARTO, but now we're adding multi-dimension support, needs CDFs. A lot of you probably working with them. We've added now the possibility to design this type of analysis with no code in workflow, so we have components specific for raster. We've done the integration of CARTO and Earth Engine, so now you can compute certain kind of like raster analysis on Earth Engine directly from workflows. And you can import also like the raster data in your data warehouse, custom base maps, many things, to make that all possible. So very excited on, how is this developing. And this is not only obviously for deforestation. This is made available for a lot of other industries, right? And raster, it is actually pretty fundamental to a lot of them. So if you think about insurance, and I know there's a lot of insurance companies here today, like they're looking more and more, they're trying to kind of have a more real-time perspective around, the impact, like of natural disasters, or essentially climate on their portfolios, right? Telco, a lot around, like signal propagations. On the health side, things around pollution, very big, like initiatives in that space. A lot of those cases require working with raster. So the idea of like having raster available, for your analytics is very fundamental. That's what we've been working a lot on that. Now, that brings me to the first strategy that I was talking about. Like, remember, our goal is to democratize access to spatial analytics. And the first strategy that I call is breaking the GIS data silo. And what I mean by that is that for a long time, our industry, we've created our own formats, our own standards, our own software. We just kind of work on ourselves, right? And you have to kind of do other type of analytics. You have to move to a different platform. And those two worlds, the analytics space and the GIS space, have lived for too long, separated. And those two things, like, are coming together. And by coming together, there's a lot of like nice things that we're going to be able to call like to make accessible to many more users. So I say let the spatial data play with all the other types of data. And to do that, the first thing, talking about raster, we're announcing a new initiative called RasQuet. We have to see if the name stays, but it's this concept of rasters in parquet. So that's what we call RasQuet. When I hear if you think the name is catchy or not. But the concept is similar to probably one which is GeoParquet, that we started 2 years ago. So the idea is like how we can represent spatial data in a format that is widely used on the analytics industry, which is Parquet. And so we've done that already with GeoParquet, encoding the data in well-known binary, and very, very big developments on that space. And now we are doing the same with raster. And we've done it, it's the same format that we already support, that we use inside CARTO. We're just trying to standardize it and make it available for everybody. So we're looking for feedback, and if you want to learn more about it, yeah, we'd love to hear from you. Now, technically how it works, think about a raster, right, that you tile, and you store each of those tiles as a row on Parquet. And the pixels of that tile, they become an array in a column in the Parquet file, right? Simple as that. Of course, a lot of other metadata associated with it and so on that you need to make it possible. But in essence, that's it. And how you encode that array of pixels, there's multiple options that we are kind of exploring in terms of native arrays or using SAR, NumPy. We can talk about that too. Well, once you have the data that way, you can actually kind of use this raster, just like if it was a regular table. And that goes back again towards, like my point around, like we need to break the GIS data silo by making rasters available just like one more regular table on your data warehouse. That opens a ton of opportunities. So I actually kind of like highlight them in here. Yesterday, I think there was a few questions around, why rasters in Parquet? And the first thing is, from my point of view, that's the first reason. It will increase dramatically the accessibility of that data to many more users. Not having to go to a specific GIS software, to do analysis on raster is a very, very big deal. So the possibility to kind of do analysis of your raster with other types of data, from my point of view, very, very big issue. The other is that now you can use, all the advanced tools that are now the market is making. We're talking BigQuery, Databricks, Snowflake. All those are the leading technology providers. So there's a lot of, that you get, by being able to integrate with them. Also very interesting, like there's initiatives around Apache Iceberg, Delta Lake, Apache Hudi that are like standardizing how we represent data in Parquets as tables. And if you think about how to design your data lake and how to incorporate geospatial data to it, that's the way to go. So I'd love to talk to you more about that. Now, that's one part. And if you look at, the state of geospatial data support from a storage perspective in the data cloud, we've come a long way. I mean, right now, it is possible to do geo in most of the platforms in a pretty native way. In the case of vector, the majority of the popular platforms already have it like native. Actually, pretty excited to announce today, Databricks has now in beta a spatial SQL, so they also have now possibility to store native vector data on Databricks. In the case of raster, still we have to do it, in the case with CARTO by adding those capabilities to those data warehouses, and also tremendous support on H3, which is one of the, I think, favorite technologies on this crowd. H3 right now is very widely accessible at the speed on all the data warehouses. Now, if you look at this diagram, there's one that actually kind of science, right? Which is the Spark ecosystem, right? And traditionally, you see with Databricks, we've been a little bit behind. So that's why I'm very excited to announce today a new version of the CARTO Analytics Toolbox for Databricks. The CARTO Analytics Toolbox is this set of functions and stored procedures and capabilities that adds on top of your data warehouse to be able to perform a spatial analysis, right? So think of the PostGIS, but for this world. And the way that we've designed it is pretty nice, because we've been working very hard together with the Databricks team to leverage their new spatial SQL capabilities. So whenever it's possible, we leverage what Databricks has built to have very, very fast accelerated photon acceleration, they call it, functions from Databricks, their native functions. And there's already 58 functions of those. But if you don't have Databricks or spatial SQL is not available on your Databricks cluster, then we default to an open source project called Apache Sedona. That's probably many of you know. It was called GeoSpark before, and it's a great, open source project that is also adding those capabilities generally to the Spark ecosystem. So there's already 165 functions on this. The CARTO Analytics Toolbox will build on it, and CARTO will start committing to Apache Sedona. That's I'm very excited about that. Now, that's the way that, we're enabling Databricks at the speed, but it also opens us, to all the other Spark cluster services that are out there, like AWS Elastic Map Reduce or Microsoft Fabric. So very, very, very excited about this development. Now, the last part on like breaking this GIS silo, and it is accessibility to data. And traditionally, accessing geospatial data is not been the easiest. And there's one project that we've been doing with the Overture Maps Foundation. So the Overture Maps Foundation is collecting data sets from different providers, started with OpenStreetMap, but now includes other data sets, and is making it available in GeoParquet files, right? And we've been working with them to essentially now make them available on BigQuery and Snowflake as native data sets on their marketplaces or as public listings. That means that you can use those data sets without having to do any ETLs, just like a join, like if it was just one more table. And it will be updated monthly. We take care of that. And that gives you access already to 600 million buildings worldwide, 500 million boundaries, polygons, 10 million POIs. All that just accessible through a SQL. I mean, like if you've in this industry, I mean, like having access to the data used to be pretty hard. And now it's just like, just there for you to use. So very excited about that, right? Now, so I've talked already about, like the first part, right? So breaking the GIS data silo means, like making, geo data part of the generic spatial analytics, right? So that's one part that, we have to work on. But the second part is how do we make GIS more accessible overall, right? We all like to think that, like spatial analytics, I mean, it's cool. I mean, and I think there's a lot of like smart people here in the room. And we have to all agree probably that not everybody knows how to read maps, even less how to do a spatial analysis. So sometimes we struggle with the fact that we make an interesting analysis and then the users do not understand it, right? That is really the reality. In fact, I mean, there's a lot of problems of understanding some of those spatial analysis as we see. So the question here, obviously, we have to talk about it, is can AI reduce this complexity? It can help us on this journey. And the obvious answer would be yes, right? You can say that there's estimated around 4 million GIS users. That's maybe a lot, but like that's what is estimated. 80 million Python users, 85 million SQL users, but there's like 370 million native English speakers. I mean, 1.7 billion English speakers overall. Or now with AI, I mean, there's 8 billion speakers. So we can talk, to spatial analysis as in natural language. I mean, that is an incredible kind of like removal of barrier, right? And obviously in 2023, we've seen an incredible amount of POCs around AIs and so on. Is that real? Is that really happening? Can it help us? I want to show you, a couple of things that I really like that I think are going to be having a very big impact on our industry and how we are using it. So the first one, and I hope that you guys have seen it because this week is being tremendous, is this concept of multimodal large language models, right? So now LLMs do not understand only text, they understand video, they understand voice, they understand images, right? And if you've seen the videos from OpenAI this week or Google on, like just talking live to the LLMs, it is mind-blowing. It is clearly, like going to revolutionize a lot of things, and it's incredibly exciting. But what it means to us, and I will show you later, it means that these AIs, these models, are starting to understand maps directly. Not the data behind the maps, but the maps itself, the actual representation of the maps, right? So that's a very big deal, like this multimodality. The second part that I want to show you is what I call the rise of AI agents. So if you're not familiar with them, it is a paradigm of how to use AI to solve problems. And the way that it works is that you ask to the AI a problem, you're asking like, I want to get this done, and then the AI resonates and creates a plan. It decides, okay, in order to solve that problem, you're going to need to do first this, second this, you're going to have to kind of do these steps. Then it goes and actually kind of like executes those steps using a set of tools like, okay, I'm going to check this, I'm going to take an image, I'm going to understand this. It's actually kind of like acting, it's doing it. And if it finds problems or it finds something, it resonates and it kind of like continues and iterates towards that, right? So that's the power of these AI agents. And there's been some incredible applications with it on different industries. So I think, this is going to be very, very, very big for us. I want to show you an example of that. So this is going back again to the beginning. This is many EUDR deforestation analysis made. And the reality is that for some organizations, large organizations, they're going to have to be reviewing like thousands, if not hundreds of thousands of maps to check for false positives around deforestation when they're like doing their due diligence. And that's a very time-consuming and honestly not sometimes very fun job to do. So this is the perfect case where you can apply an AI agent to that. And that's what we did in here. As it works, yeah. So this is, and you can see here, we've added, what we call CARTO AI agents. We'll show you in a minute. And we are asking directly, what is the status of this particular farm? And the AI is taking a screenshot, is filtering, is using the product to actually resonate and gives me a report and say like, yes, this farm actually has high risk, and it's because we've seen deforestation alerts in certain parts of the farm. So this is what we're like looking in here. So I'm very excited to announce, the availability of what we call CARTO AI agents. Essentially a technology to effortlessly create, so that you can create AI agents that operates, analyze, and reason with your maps. And you don't have to code to actually make them, to have them ready. So I want to show you how it looks. It's very cool. So RMX is one of our customers. They are like a logistic operator in the Middle East, and they do a lot of these last mile deliveries, right? So they work with us on the beta of this program by creating, in this case, like in this map, I mean, like the operator is enabling, like an operator to see what is the deliveries and the actual stations when things are delivered. So you see now I've opened, in this case, like the CARTO AI agent. It's giving me a few examples of questions that I make this map. The person that designed this map is helping to create this. And now the user is asking a specific question around the percentage of shipments delivered by a specific branch. And what is happening under the hood is the CARTO AI agent is first designing the plan. And what you see now is doing is taking control over the map, over Builder, over CARTO, and start operating it. It's choosing the options on the interface, is filtering first by branch, is then doing, I believe now it's doing an isochron to get, like what are the areas around, like a specific branch. It's deciding what are the steps needed to answer the questions by utilizing the map and taking the screenshots on all the processes to see what it's seeing, and it ends up, telling us, like out of total, like this tells me, like 61%, and it highlights the specific like brands that I was asking on this question. So what you see here is like a user designed a map to answer a set of questions, and then someone used this map that was created by the user with an AI agent to just, with natural language, utilize it without having to understand all the options that the map has. So I think that's pretty mind-blowing when you see it. I actually didn't show it, but the fact that it can get control over CARTO is also a great way to learn how to use CARTO, because you actually get to see what is the decision that it's making to solve a problem. It is pretty mind-blowing. I want to show you a few more examples. We work with BT. BT is doing a great project. You should ask them. They're here, they're sponsors. They're transforming these green boxes into electric vehicle charging stations here in UK, right? So again, in this case, someone at BT has produced a map to help those who are planning on this transformation decide where it's better to start doing these transformations, right? And in order to do that, again, another CARTO AI on top of the map, and it's just making a pretty complex question, right? In terms of a question that only you will understand within the context of this map, right? And it's just giving you straight away the answers in here just by looking at it. So that's another example that I really like. Now with View, it's another of our customers working on. They have this out-of-home advertisement platform, so they have a lot of frames on the streets. So they have a map created with CARTO that allows someone to design a campaign. So in this case, what you're going to look at, it is the operator in this case is asking I'm trying to do I'm doing a campaign around cars in Lisbon. Can you suggest me the places where I should be looking at, right? And the map and the AI has actually choose has zoom in, has filter, has the multiple steps towards doing it. Right, it resonated, and it's giving me the context. And I highlighted this example because I found it like mind-blowing that by taking the screenshot of the result of the analysis, the AI resonated which neighbors were, like the data in, what are the characteristics of the different neighbors in terms of, like their demographics and so on. So to me, I mean, this is actually a great example of something that I don't know if you're aware, but these LLMs, these big models, GPT-4, Gemini, are getting trained already on geography. So they're able to resonate on things like this, which is pretty mind-blowing too. A few more examples. Yeah, Mercado Libre. Mercado Libre is the leader e-commerce and marketplace in South America. And one of the services that they provide is financial services for stores to essentially like to be able to charge to customers. So it's part of, so they have like a project to try to get to as many stores as they can. And so the geospatial team, again, has designed an interface where like the operators can actually look at what is the potential of a specific locations. So in this case, we start a little bit different. The user starts by selecting a location and say like, hey, I'm considering this location. Is this a good location for, or what are good stores around this location to target for what we're trying to do, right? And the reason why I'm highlighting this is that in this case, the map itself that was designed by the geospatial team do not have all the data that is actually provided in there. But actually, when you design the map, you can allow the AI agent to do what's so-called RAG. We allow it to say, like, you can go to the data warehouse and query in SQL to the source tables to complete your questions in case you need it. And that's how you get this very, very rich type of reasoning, around, like, first of all, like social demographics, all this, you will get it out of the map. But then like the categorization into type A and so on, that comes out of the database. So it's not only what you see in the map, it's what the AI can actually do to access it. So all of this, as I say, is designed using CARTO Builder. So the existing mapping interface that you have is where the user, the creator of the interface that knows what it's trying to solve. And let's not forget this is not a totally empty canvas. No. The person that knows, okay, I'm trying to help users to find what are the best locations for this. And for that, these are the pieces of information that are relevant to help on that. It's designing this AI agent by making all of that and providing the context, saying like, this map is useful for this and that and that and that, right? It can then also choose capabilities, like do you want to allow it to query your database on your name, etc. And then it can provide examples of what it can do. Examples and results for those examples. So you can fine-tune the model to essentially what it needs. And then automatically we collect all the information that we can from widgets, descriptions, and so on to provide more context to the model, right? So that's how you actually design it. There's one more thing I wanted to show you. Let's see if it works very quickly, because I know I'm going a bit. But all of this, you can also access it through APIs. It's just very, very cool. So what are you seeing in here? We have the same deforestation agent that I demoed connected to Slack. So I'm going to say like, hey, how can you help me? And let's see if it works. So now, the Slack is connecting the CARTO AI agent that I generated for deforestation, and it's saying, yeah, I'm an EUDR compliance assistant. I'm here to help you to make questions around that particular reports. So I'm just going to kind of go in here because I have the question. So an example question here would be, hey, what is the status of a plot related to this mill? Very specific question for this type of agent, right? I don't expect everybody to understand it, but someone working on this company knows that, like that's what they want to do. And you see now it's telling them, like the result, which is like, hey, yeah, it appears there's only one plot with this ID. This plot shows recent deforestation within its boundaries, indicated red flag areas. So watch out. And by the way, here's a link that you can click, and it will open the report to that specific in case you want to look at that further. So I think that's amazing, that you can do connect all these pieces together so easily. And that also will open, your minds around how can you integrate these AI agents in your own applications, or how we can make agents that talk to other agents to concatenate stories, right? So pretty exciting things. Yeah, I want to finish, first of all, by thanking, like a lot of those customers that have been part of our beta. CARTO AI Agents will become available this summer, but if anybody of you are interested in like joining the beta, please talk to us. And also, obviously, a lot of the data cloud partners that we work with, because a lot of these LLMs are now made available on those infrastructures. So we're working very close to them. So thank you for them. Now, just finishing, I talk about these two things: how we democratize spatial analytics, consider breaking the GIS data silo, and utilizing AI to make your applications more accessible. So I hope you find that interesting, and I hope that you guys have a great conference. Thank you.